Right, question 7 is a question about capacitors. We have a circuit and S initially is open, that's shown, and the capacitor is initially uncharged. Just notice that the cell that's shown, the long end indicates the positive end, the short end, the negative end. We're going to need that a little bit later. It's in series with a 10 kilo ohm resistor, and then there's our capacitor, parallel plate capacitor. Alright, 7.1, define the term capacitance in words. Just a definition to learn. Capacitance is defined as the amount of charge stored per unit of potential difference. The amount of charge stored per unit of potential difference. Right, 7.2 is a calculation. Capacitance is given, 5 times 10 to the minus 12 farads. Distance between the plates is 1 millimeter. Again, be careful of units. SI units need to be meters, so we're going to need to do a conversion. We're told that it's square in shape, and the question asks us to calculate the dimensions of each plate. We're also told that there's air between the plates. The significance of that is that the nature of the dielectric should appear within the formula, but the one that you're given in your data book doesn't include K, which is a dielectric constant, but in the case where it's air, that K just equals 1. So the formula is capacitance, C, is equal to epsilon naught, the permittivity of free space, times A, the area, divided by D, the distance between the plates. So capacitance we're given, 5 times 10 to the minus 12. Epsilon naught's a constant from your data books, 8.85 times 10 to the minus 12. The area of the plate is what we're looking for, and the distance is 1 millimeter, but we need to convert that to meters, so 1 times 10 to the minus 3. That allows us to calculate an area of the plates of 5.65 times 10 to the minus 4 square meters. So if that's our square plate, then obviously it has equal sides, and to calculate the length of the side we need to take the square root of A. So we work out the square root of 5.65 times 10 to the minus 4, and that gives us 0.024 meters. And so the dimensions of the plates in our capacitor is 24 millimeters by 24 millimeters. Alright, switch S is now closed. What will be the polarity of the plate of the capacitor marked Y? So there's our circuit diagram. Remember that the long end of the battery is positive and the short end negative. And so if we follow the positive side round to the parallel plate capacitor, the positive end of the battery is connected to plate Y, which means plate Y will be positive. The negative end is connected to the other plate, and that will obviously be negative. So the answer to the question is that plate Y will be positive. Alright, last question, the potential difference across the capacitor versus time. Remember, even though you're sketching a graph, you're still using your ruler where necessary, so draw your axes with rulers, label them carefully, potential difference symbol V, units in volts, put that in brackets, against time, small t, seconds in brackets as the units. And when a capacitor charges up, there's a rapid increase in potential difference, and then slowly as the capacitor gets fully charged, the potential difference remains a constant, and so the graph looks like that.